Alright everyone, welcome back to part 2 of this video. I remain Sade from High Achievers Academy. Now, let's continue from where we stopped. We stopped at addition and subtraction of complex numbers. Now, let us go into something different. Let us look at the Argand diagram. Though it's not that hard, but before we get there, there's a part I want us to hit, and we will be taking a look at the application of this complex number. For example, how do we get the final answer to this? The final answer to this was just to call, remember we stopped at x is equal to square root of -1 from the last example. What is the final answer? The final answer is still this, x is equal to I. That is the final answer here, an imaginary number. Let us look at other examples of this. Let us look at other examples of that. So this is one example we can look at, and here is the solution to that. Now, if we are to solve this normally, we would have x squared minus 2x plus 2 is equal to 0. How do we solve this? We can solve this by factorization, but most times when you're dealing with something complex number, you would want it will normally be possible to factorize. So let's just go straight into the almighty formula. I'm sure you remember this formula: negative b plus or minus square root of b squared minus 4ac over 2a. So that will just be a reference. So if you are to solve this, what do you do? Let's solve it normally. Take away what you know about complex numbers for now. This is an application. You have to solve this. You're asked to find the solutions of this number. So what do we have? We would have, what is our b? Remember, this is our a, this is our b, this is our c. So our a is simply 1, the coefficient here. What is b? Our b is simply -2. What is c? Our c is simply 2. Now let us put everything back into the formula. So what do we have? Minus, then what is b? -2 plus or minus square root of b squared minus 4. A is 1, c is 2. All over what? 2a. What do we have here? Would have 2, positive 2 from here, plus or minus square root of b squared. -2 all squared is equal to -2 times -2. Negative times negative, positive. 2 times 2, 4, positive 4. So -2 all squared is positive 4. 4 times 1 times 2 is 8. So this is 4 minus 8 all over what? 2 times 1, which is 2. What do we have next? We would have 2 plus or minus square root of, what is 4 minus 8? 4 minus 8 is -4 all over 2. Now, in past times, before you know about complex number, we would normally say this is not possible. What I mean is that in primary school, if they're giving you normal simple things, what is 4 minus 2? You simply say 2. You say, what is 2 minus 4? You say it's not possible, because at that stage, at that step, you don't know anything about that. It is not applicable to you yet. But now you are no more in this stage. You are in this kind of stage. Before, let's say you normally meet 16, you take the square root of 16, which is 4, and then continue and say 2 plus or minus this. But now, even if you're getting a negative, this is the application. With the presence of a negative, you still continue and say 2 plus or minus. Now, what is the square root of -4? We'll look at how we can break this down further, but this will be simply, what is -4? You can break this down into two things. Anytime you're dealing with complex number, you can break it down into two things. So -4 can be broken down into square root of -1 times 4. If you look at it well, minus 1 times 4 is still this negative 4. So you continue and say, you separate it. You can separate it since they are both being multiplied. You can say square root of 4 times square root of what? Negative 1. Now, what is the square root of 1? 2. What is negative square root of negative 1? Is simply I. So this will be your final answer, 2i. More examples on this later. So that is 2i. So here will be what? 2i all over 2. So what else do you do here? 2 plus or minus square root of 2 plus or minus 2i over 2. You can simply factorize this. So this will be, bring out 2, and this will be 1. Like, this is a whole number, factoring out 2. So 2 into 2 is 1. 2 into 2 here is still 1. So you'll be getting plus or minus I. Then this will be all over 2. So these 2 can simply cancel this 2. What are you left with? 1 plus I. Now this will be your final answer here. Sorry, 1 plus or minus I. So it's either it is 1 plus I or 1 minus I, and this will be your final answer. So these are applications, and there are other examples we can take. Let us take this simple example, but this is if you are given a quadratic equation and you are getting a negative here, you can further still reduce it down to a complex number. So the final answer has a real part and has an imaginary part. If we go further and say, what is the square root of 9? You can simply say the square root of 9 is what? 3 times 3, which is what? Square root of what? Not square root again, sorry, which is simply 3. You pick out one number. But now, okay, let's still continue. Square root of, let's not do something simple. 25 is still what? 5. Now, what about when we are given what is the square root of negative 9? What do we do? Like we did up there, you simply do what two numbers can multiply to give me negative 9? They are simply 9 and what? 9 times minus 1. Then you further break this down to say this is square root of what? 9 times square root of negative 1. Ladies and gentlemen, we are still here. Square root of 9 times square root of negative 1 will still give us 9 times negative 1. 9 times negative 1 will still give us negative 9. So we can continue and say square root of 9 is what? 3. Square root of negative 1 is what? I. This is the final answer. Let's take another example. Let's see, what is the square root of negative 25? This will simply be square root of 25 times 1 times negative 1. Since they both get this will be square root of 25 times square root of negative 1. And this would be 5. Square root of negative 1 is what? I. Remember, I is equal to what? Square root of what? Negative 1. This is where we are getting that negative, that I from. All right, so we'll take a few more examples from here. All right, let's take other examples. Let's try to get the square root of negative 18. Remember, these are still applications. What do you do? Now, it might not be just as straightforward as 18 times minus 1, because now, what is the square root of 18? To simplify it further, there is, but instead of going through this way, what we just do is that from here, we should already know that this contains a minus 1, right? Now, what are two numbers that will multiply to give you 18? There's a lot of numbers you can multiply. You can multiply 9 times 2. Other numbers, but basically, what would be the simplest? That would have a perfect square will be 9 and 2. So if you check this out, 9 times 2, 18. 18 minus 1. 18 times minus 1 is what? Negative 18, which is what we still have here. So you can now further break this down. Remember, like we broke this down to what? Square root of 9 times square root of 2 times square root of 1. So this square root of 9 is what? 3, square root of 2, leave it as square root of 2, and then this negative square root of -1 would just be I. So this will be our final answer. Square root of 3, 3 root 2, and then I. Let's take another example. Let's take square root of -50. Now I'll simply break this down because I know what number will multiply will have a perfect square to give us 50. 25 times 2. Then I'll still add my -1. Then this would be square root of 25 times square root of 2 times square root of -1. Square root of 25, 5. Square root of 2, still 2 when they multiply. Square root of -1 is I. This is our final answer. Let's take one more example. Let's take, what is this? Negative square root of -72. Now, this would be, now, if you have a negative in front, leave it in front for now. We will leave it in front for now. So let's just write negative, and then what are the numbers we can multiply to get 72? This is just the tricky part, if I would say. We can simply multiply 36 by 2 will give us 72, and then we continue leaving this minus still in front. All these 36 times 2 is 72. 72 times -1, -72. So this becomes, this negative is still in front from here, not this one. This negative carries over here. So this would be negative square root of 36 times square root of 2 times square root of -1. This would be, square root of 36 is what? 6. So this is -6. Square root of 2 still remain square root of 2, and square root of -1 gives us I. And this would be our final answer. Our final answer is -6 square root of 2 I. Now, after this, we can, if you think about it, even if we are getting our final answer as 3I, 5I, and whatnot, how do we represent it? What do I mean by that? We are getting our final answer as 1 plus I, or 1 plus 1I. In other examples that we did in the last class, we were getting 23 plus 9I and other kind of numbers. Basically, we can represent all this in an Argand diagram. And this is how it looks like. This is an Argand diagram. An Argand diagram is just a graphical or a pictorial representation of complex numbers. That's basically what it is. So what is going on here is just like your normal number line, your normal real number line, where you have your x-axis and your y-axis. And then you have numbers 0, 1, 2, 3. This will be the negative side, -1, -2, -3. This will be -1, -2. This will be this, and so on. It's the same thing. This is what you call, this one I just did, this is what we call the Cartesian plane. Now, if you want to put something like that on the Cartesian plane, if you want to represent a real number, let's say we are to represent 6 plus 7I. How do you represent it? And this is a complex number. You can't really play, you can place 6 here. Okay, let me start now. Now, your x-axis, this is our x-axis. Let me write it, x-axis. Your x-axis is your real part. Remember I said this is a real. While your y-axis is your imaginary part. Your x-axis is what will contain all the real numbers. Your y-axis is what will contain the imaginary part. So whenever you want to represent a complex number pictorially or graphically, just take a look. Remember, of this form, remember I said the name of this form is what? If you can remember, when you have something like this, when you have something like a plus bi, You can call this Cartesian form, or you can call it rectangular form. So a plus bi. Remember, the a part is your real part, the b part is your imaginary part. So the one with I is your imaginary, the other one is your real. 6 is our real part. So 6 is our what? Real, and 7 is our imaginary. So if we go on here to plot it, where is 6 on the real axis? This is 6 on the real axis. So you're going to draw it up. Now, where is 7 on the imaginary? Okay, first of all, before we get to that, where is 6? 6 is here, right? We can all see it. Where is 7 on the imaginary? It's I. So this has I. Where is 7 here? This is 7. So how do we represent 6, 7 on an Argand diagram? Or how do we represent 6, 7 in complex form? We represent it by drawing or finding, locating 6 on the real part and locating 7 on the imaginary part. And then we trace them together. So where is 7? Sorry, let's start with the real. It's easier. Not always easier, but I prefer starting from the real. So we draw a straight line till we get to 7, and then we also match it up. So the final representation would be something like this, where you just draw from. Now, one thing, whenever you're drawing or representing it, after you've marked the real 6 and you've marked the imaginary 7, just take from your origin. Your origin is 0. Your origin, you take from your origin, mark it down to where they intersect, so which is here. So this is the representation of 6 plus 7i. You can represent many other things. I hope you've written this down so I can clean this off. So please write so I can represent something else on here. So let us represent this number. Z is equal to 4i minus 8. Now, this, don't be confused. This is the imaginary part. Anyone that has I, this is the imaginary part. What are we having? 4. So where is the imaginary part here? 4 on the imaginary part is where? Here. On the real part, the one that does not have I, where is negative 8? Remember, negative 8. Negative 8 is here. We mark it. Now, remember, we trace them down. Let me trace them with something more legible. Let's trace this down. Also trace this way. And then, remember, after tracing, after marking your location, take from the origin down here. And this will be your final representation. All right, so let's do one more representation. Let us represent, let's say, negative 8i plus negative 8. So where is negative 8i on the imaginary? Negative 8 on the imaginary line, which is here, is here. Mark it. Where is negative 8 on the real? Negative 8 on the real is here. We mark it. So we trace it down, or if you don't want to trace it down, just eyeball it if you want to, but just simply this. And then the actual line would be from the origin down here. This will be your final answer. Your final answer would look like this. So, this is how we represent numbers on an Argand diagram. Before we move on and complete this, let's take a look at what we'll be learning in the next lesson. We'll be looking at powers of I. We'll be looking at finding the modulus, amplitude, and absolute value of R. We'll be looking at forms of complex numbers and so on and so forth. So in the next class, We'll be looking at finding modulus, amplitude, absolutes, and finding R. We'll also be looking at powers of I. Thank you very much. I remain Sadif, and please do not miss the next video. Thank you.